Hello class. Today we're going to start our lesson on electricity. In this particular lesson we're going to be looking at SAP 5B. SAP 5 actually talks about electricity, magnetism, and gravity. We're just going to focus on electricity in our video lesson today. We're going to be looking at the advantages and disadvantages of series and parallel circuits and how they transfer energy. Let's take a look at our two learning targets. And the learning target, remember, is the whole objective of these lessons. By the end of these lessons, we want to be able to do what these I can statements tell us to do. I can explain the difference between series and parallel circuits and how they transfer energy. I can demonstrate the advantages and disadvantages of series and parallel circuits by building simple series and parallel circuits. So by the end of our lessons, we want to make sure that we have met these particular learning targets. Please make sure you write these targets in your notebook on your student-friendly standard sheet that you were provided with in class. Write these on your paper. All right, let's jump into our vocabulary. You should now be looking at your electricity tip chart, which you were given a copy of in class. Make sure that you include information on this chart as well as a picture on this chart. Let's look at our first word, which is electricity, which is basically the focus of our lesson. Electricity is produced by the movement and distribution of charged particles known as electrons. Now, you remember way back at the beginning of the school year, we talked about atoms. Atoms is the basis of a lot of things that we talk about in science. Electrons are part of the atom. So when these charged particles start moving around, that is how we produce electricity. Current. Current is the flow of electric charges. So as these electrons are flowing along a path, that is what we would call electric current, which is going to be a big part of what we talk about as we get further into our lesson. So I want you to start using that word current. Instead of saying the word electron, we're going to just say the flow of these electrons is what we would call current. Now, current, like I said, has to have a path to move along, and typically when it's moving along this path, it's going to flow from an area of high energy to an area of low energy. If you look at this particular picture that we're looking at here, this arrow is showing you the direction that the current is flowing along this path. In this particular example, your battery is your energy source. That's where the energy is coming from. So it's going to move from the negative end or negative terminal of the battery, which is considered high energy, around to the positive side, which is considered your low energy side. And that's what we call current. Okay. Now, the path that this current is flowing along is what we would call a circuit. A circuit is a closed path through which electricity can flow. Energy flows only through a circuit that is closed. Opening a circuit will stop the movement of those charged particles or stop the movement of the current. So current is what will flow along this circuit. Okay, so now we're kind of starting to see a relationship between these words. Current will flow along a circuit, and the path has to be closed in order for that current to flow. This picture that we're looking at here is a simple circuit. You are looking at a light bulb, a battery, and then the path, which is normally going to be some type of conductor, which when we're talking about circuits, it would be wire that the electricity can flow through along this particular path. Let's talk about some different parts that make up the circuit. One part of the circuit is called the load. The load is a device in a circuit that operates using energy that is delivered by the electric current in the circuit. So anything that's using the electricity that is provided in the circuit is what we would call a load. An example could be a light bulb, a bell, a radio, a motor. Anything that you have in your house that works off of electricity would be considered a load in a circuit. A switch is another part of a circuit. Switch is something that we're very familiar with. We use them all the time. We want to turn lights on and off in a room. It is a device that is used to control the flow of current through a circuit. If a switch is open, the flow of current will stop. If the switch is closed, then the current will flow in the circuit. And we're going to use a switch, example of a switch, in our simple circuits that we will be building this week. I want you to think about if your lights are off in a room, would your circuit be open or closed? Okay, if the lights are off in a room, if you said the circuit would be open, that would be correct. Because if my circuit is open, that means current is not currently flowing through my circuit. And then once I close my circuit, current will flow. And you can do that, turn the current off and on in a circuit by using a switch. Let's talk about the two different types of circuits that are mentioned in our standard. The first circuit is called a series circuit. Remember, a circuit is a path along which current can flow. Well, if there's only one possible path for the flow of current, that is what we would call a series circuit. And if you notice here in this particular picture, there's only one path or one way that electricity can flow along this circuit. The current is always going to start flowing from the battery because that's your energy source, and it's going to make its way around the circuit, going from an area of high energy to an area of low energy, and there's only one way for that to be done. So that is what we would call a series circuit. I want you to also notice in this picture at the top, this would be the switch. And this particular picture, it's showing you the symbols that you would use to represent the different parts of your circuit. And we're going to practice drawing some circuit diagrams. But I want you to look at this picture. In this particular picture, is the switch open or closed? If you said the switch is open, then you would be correct. So in this particular situation, we would say that current would not be currently flowing in this particular picture because your switch is open. Just to kind of give you an idea of what we're talking about when we say an open and a closed switch. These are two pictures that are pretty much showing us the same thing. The only difference is here we're using the actual parts or pictures of the parts that make up the circuit. The top picture is showing you more of the symbols. And like I said, we are going to practice drawing these diagrams both ways. We'll practice it with the symbols, and we'll practice it with just where we draw with just what the parts would actually look like, just so that you're familiar with both, because you will see both of these. Let's talk about the parallel circuit. Now, the series circuit has only one path. The parallel circuit, however, it's going to provide more than one path for the flow of electricity. So once again, if you look here, now there's more than one way that this current can travel around the circuit. Of course, like I said, it's going to start at the battery, which would be here. This is your symbol for the battery, and it's going to flow around. It can go, this could be a path that it could take. It could also go this direction. Okay, so there's more than one way for that current to get around the circuit, and this is the same thing here. It has more than one way that it can get around that circuit, more than one path for the flow of current to get around that circuit. That concludes our lesson on electricity. Please make sure that you have completed all of your notes for your tip chart, and that tip chart should be attached in your notebook. Please make sure that you attach that in your notebook.